board. Okay, so the first concept in the second lesson is the domain of the logarithm function. So as I said in the class notes, whatever number goes here cannot be negative. You can't do a power of 5 and make a negative. Likewise, you can't have a 0 here. There's no power of 5 that makes 0. This is nonsense. It doesn't work. So this is what I'm looking for. So my first step, step 1, is to take the inside part and make it equal to 0 and solve it. I mean, I can move this to that side. It doesn't matter. I'll subtract 4. You know, this is a linear equation. Don't get too cute with this. Divide by -8. Right? Now, negative and negative make positive. So that's 1/2, right? Reduce it. 4 divided by 4 is 1. 8 divided by 4 is 2. So this number will create a 0 inside of there, right? See, 0. So this number is a freak. I'm going to take this dude now for step 2, and I'm going to put him on the number line, just like I did before. I'm going to pick a number on this side as a test point. I'm going to pick a number on that side as a test point. You know, you can pick whatever you want, but I have 1/2, so I may as well pick 0 and 1. You can pick anything. Then I'm going to plug these numbers in and see if they work, right? I have 4 minus 8x. So when you put 0 in for x, 8 times 0 is 0, so you get a 4. That's positive. Yay! I already know I'm done now. Now, if I do 4 minus 8 times 1, test point, you get 4 minus 8, which is -4. These are the freaks. These are all gone. So my domain, my big D, remember, this dude is a freak. He makes 0, so you got to throw him away. So my domain, my big D, which I have no room, is from 1/2 and below. So it's from -infinity up to +1/2, not including him. That's the domain. Now, I'm not going to have room there, so I'll erase this, and I'll write this down there. All right, so I just transferred it to the bottom here. So now I'm going to do this one. I'm going to do the same steps. I'm going to take the inside, set it equal to 0. I'm going to solve it. You can either factor it, or you can move that number over and take the square root. That might be riskier because you might miss a root. X equals plus or minus 1. Some people, when they do this, when they go this route, where they add the 1 to that side and they take the square root, they forget the plus and the minus. So once you forget the plus and minus, you're completely screwed. So maybe that's not the smart way to do this. Maybe it's smarter to factor. You know, as long as you remember the plus and minus here, get the right answer. But I see a lot of people miss that sign. So, you know, maybe that's not the best thing to do. Now, step 2 said, take the numbers you got, put them on the number line. Now pick test points. Let's do it. Let's pick 0. Let's pick 2. Let's pick -2. Now, same thing. I gotta plug them into where? I gotta plug them into here. So let's do this a little faster. If I had -2, -2 squared is 4. 4 minus 1 is 3. It's positive. If I put 0 in there, 0 squared is 0. 0 minus 1 is -1. Oh, there's my freaks. And again, you're going to get the same thing when you plug in 2, that you got 4, take away 1 is 3. So he's cool. He's cool. All your freaks are here. Freaks, throw them away. Remember, this dude, positive and -1, make a 0. The log of 0 is undefined. The log of a negative is undefined. So you have to throw away -1, and you have to throw away 1. You just keep everything out there and out there. So the big, let me erase the word. The big D is going to be from -infinity up to -1, not including -1. And remember, we write a big ass U for union, and then from 1 to infinity. So all those numbers are cool. All those numbers are cool. All the numbers in the middle, 0, a half, -1/2, a third, a fourth, all those numbers are freaks. All the numbers between -1 and 1 are freaks. We throw them away. So that's the domain of the log function. All right, so the second topic of this lesson is going to be to join the logarithms that are separate into a single logarithm. We're going to do this because we're going to solve equations with logarithms later, and we're going to need to use the properties to combine them. So I'm not doing this for no reason at all. Now, the first property was that when you have log of something to a power, that power can go in the front. So what I'm going to do now, these rules go both directions. They go both ways. So I can start here and then end up there. Now, if I'm going to combine these together into one, I don't want the power in the front. I want to move it up. So my first step is going to be to do that. I'm going to use the reverse of that property. The powers are going to come up here. Oh, I wrote y both times. I meant this to be an x. So here, x. I don't want them to combine after. So I'm going to have ln x to the 1/2 power plus ln y to the 8th power. You move the powers up. This is the opposite of the rule. Normally you'd move them in the front, but I'm trying to combine them. Now the sum, if you ever forget what it was, remember that when you multiply letters, you add the powers. So when you see addition, multiplication, right? You multiply letters, you add the powers. And these are inverses. So any property that works for the exponents works for the logarithm. So addition becomes multiplication. So now, instead of having two separate logs, I'm going to have one. Now let's be more sophisticated here. X to the 1/2 is radical x times y8. Here's my single logarithm. I took two different ones and wrote them all as one. I move the powers to the top, and then I add, becomes multiplication. All right, so that's the first one. Now I'm going to do the second one in a minute. All right, so now I'm going to do the second one. I'm going to do the same first step. I'm going to move all the powers to the top. So the 3 is going to go up there, the 5 is going to go there. And now you got to be careful with the 4. So I log x3. The 3 just goes on top of the x. The 5 hits the y. Now here you got to be careful. I'm going to move the 4, but you have xy there. So when you do that to the 4th power, you have xy, 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 xy. So you have 4. You have 4 x's and 4 y's. So this is x4, y4, right? So you have to be very careful with that part. So minus log x4, y4, okay? Now I got to start combining everybody. I already know that when I have the plus, I do multiplication. So I'm going to take those two and put them together as one. x3 times y5. Now I have this dude over there waiting. Hopefully you'll see what's about to happen here. Now, remember, when you divide exponents, you subtract them. So subtraction and division go together. Multiplying and adding go together. Subtracting and dividing go together. So when you see the minus with the logarithms, it means you divide whatever is next to them. So this is going to turn into division. So now I have one log. Everything here goes on top, and everything here goes on the bottom. Now we got to be a little more sophisticated, right? We got to do our subtraction. x3, x4 leaves you with an x on the bottom. y5, y4 leaves you with a y on the top. Now I'm going to show you real quick a mistake that I see all the time. I tell people to do log x minus log y. You want to know what people write? They go log x divided by log y. This is not a single logarithm. It is a very easy mistake to make that people will do this question and they'll do this. They'll write the log on the top and they'll write the log on the bottom. It does not work that way. It's a single logarithm. You are dividing the people that are next to the log, not the logs themselves. All right, so try to avoid that mistake. One of the other third problem type that I'm doing in this lesson is to show you how to solve an exponential equation that's not nice. Something like this is easy. The power of 2 that makes 16 is 4. You can do this in 2 seconds without any work. But here, First of all, this is not a power of 2, clearly. This is an odd number. Powers of 2 are even. So what your first step is going to be is to take the log of both sides. Why am I doing this? You need to use the logarithm property that takes this and moves it into the front. So that's why I'm doing this. So I take the log of both sides. Step 2 is to take that power and move it into the front, multiplication, right? That was the log property. The property says if you do log of something to a power, you can put the power in the front. You're going to use this constantly, so it's very important that you understand it. Now, I want to solve for x. This is multiplication. So you divide. Whoops, I wrote 21 instead of 121. Dope. So log 2. There you go. Now, I just need to figure out whatever the hell that is. So, yeah, let's go to my graphing calculator. And I'm going to put log 121, be careful here, parentheses, divided by log 2 equals 6.9188. I will always round this. Now I want to check. I want to show you something. I'm going to do 2 to the 6.9188. It's not going to be exactly 121. See how close it is? Instead of $121, it's $120.99. That's good enough. That means you got the right power. Okay, so I know that I did that question right. So the more you round, the less accurate your answer is going to be. So you want to be super safe here. You want to go a minimum of 3 or 4 decimal places to make sure that you do this accurately. All right. Now I'm going to do the second one in a minute, and I'll show you. Okay, so the second one, I'm going to take the log of both sides again. This is how you solve it. It's going to tell you solve the following using logarithms. So if it says that to you and you don't do that, then I'm going to mark you wrong. This comes in the front. Now, here's the part where you got to be careful. When you move this in the front, you know, if you had x minus 1 times 3, say, the question is it the same as x minus 1 times 3? Now, this is a rhetorical question that you don't answer. This is not the same. This one here means 3x minus 3. This one means x minus 1 times 3, which is x minus 3. X minus 3. So these are not the same. The point I am making to you is that if you don't put parentheses here, it's going to be marked incorrect. Now, I won't mark the whole question wrong, but I will, if I have to write the parentheses there for you, I will deduct a point. You have to make sure you write it correctly because it doesn't mean the same thing if you don't. Now, I'm going to divide by log 3. So what's left on the left? What's left on the left? X minus 1. I need to compute this, so I will. I'm going to go back to the calculator, and I'm going to compute it as quickly as I can. Share, pal. I have the other one still in there. So I'm going to do log 348 is what I had on top. You got to put the parentheses there. It's going to give you a completely different thing. So be very careful that you close the parentheses. And I'm dividing by log 3. Here you don't have to close them because I'm not doing anything else. So I get 53269. 53269. So I just wrote that on the board. Stop share. Okay. So that's what I got. I computed this. You got to compute this. You got to do the number. Why? Because I'm solving for x. I don't have x. I have x minus 1. So I got to do x plus, I got to do plus 1 for both sides, right? To get x alone. So then x is going to be 6.3269. That's the answer. And again, you could plug this in up there, right? And you'll end up doing 3 to the 5.3269 power. You're not going to get exactly 348. You're going to get like 347.99 or something like that. But that's the answer. All right. If we went more decimal places, it would be more accurate. But this is good enough. All right. So that's the second one. Solving basic logarithm equations. you're going to be doing this a lot the next class. That's why I'm introducing it now. Now, this doesn't use any of the properties that I showed you. However, it does use converting. So again, I'll remind you how it works. Exponential function is base power, and you get this answer. The way the log function works is the base goes there. The answer you got goes here, and the power is on the other side. I know I write my P weird. So there's your base, there's your power, there's the answer you got. So if I want to solve this equation for x, I need to convert it first into an exponential equation. So I'm going to take 2, which is my base. So 2 to the third equals that. So 2 to the third power is equal to this dude, 3x minus 4. Now, do 2 to the third, which is 2 times 2 times 2, which is not 6. And then solve it. I mean, this is a friggin' joke. I mean, how long is it possibly going to take you to solve this thing? 8 plus 4 is 12, divide by 3. Yay! You get x equals 4. Now, I want to check real quick and just make absolutely certain. First, plug this in here and make sure, back to the very first thing I did today, which was the big D, the domain, you make sure when you plug this up in there that you don't get a negative. Because if I plug this in and it made this negative, it doesn't. But if I did, I would reject this answer. This answer would be BS. So I want to make sure that it works. So I'm going to do that. Log 2, that's 12 minus 4. So I get log base 2, 8. So what power of 2 is 8? Son of a bitch, it's 3. So as long as you get the right thing, I know that this is 3. So it checks out, right? This is how you check. You make sure, this is super important. You're going to do ones later that have something like this in it. I mean, I'm just making up an example. So here, you're going to get 2 answers. And I promise you, one of those answers when you plug it in is going to create a negative in there, and you would have to reject that answer. You get 2 of them. That's more advanced. That's the next class, but I'm introducing it to you to show you. So that's not what was there. It was 3x minus 4. It was easy one. You get one single answer. It worked. I'm good to go.